Hello everyone and welcome to Thinking with Mathematical Models 4.3. Our learning target today is I'll be able to match a correlation coefficient with a given scatter plot. You might be saying, what's a correlation coefficient? Well, that would be a great question, and we answer it right down here as our definitions. A correlation coefficient measures the strength of a linear relationship. If you want to look that up, it will be on page 87. The correlation coefficients fit on a range between -1 and +1, and we'll get into what that means here a little bit later. Another vocabulary word for investigation 4.3 is outlier, and that's points on a scatter plot that don't fit the pattern. They lie outside the cluster of points. So as you can see here, most of the points are here close to this line, but then there's a couple out here. They're way out here, so they are outliers, okay? They lie outside of the normal pattern, and that will be our outliers. As we talk about the correlation coefficient, if we have an upward slope of our line of best fit, we are going to have a positive correlation coefficient, something greater than 0 and less than or equal to 1. If we have a downward sloping line of best fit, then we are going to have a negative correlation coefficient, or something below 0 but greater than or equal to -1. If there's no correlation at all, meaning that the dots are just everywhere all over the grid, we have a correlation coefficient of 0, meaning 0 strength with that model. Our ACEs for 4.3 are going to be 6, 8, 19, and 25, beginning on page 100. So 4.3, correlation coefficients and outliers. We're dealing with roller coasters here and how they might differ in maximum drop, height, track length, ride time, and coaster type, meaning wood or steel. So we're going back to an earlier investigation and grabbing some more information here. It says, which roller coaster variables do you think are strongly related to the top speed of a ride? So of these things, drop, height, track length, ride time, and coaster type are going to be more strongly related to the top speed of a ride than others. Again, correlation coefficient, we have the definition earlier that I wrote down for you, and this is on page 88. And it tells you that the number is a decimal between -1 and 1. Again, a strong positive line is going to be closer to +1. A strong negative line is going to be closer to -1. And if it's all over the place and there's no real pattern or real good line of best fit, that correlation coefficient is going to be closer to 0. Part A on page 88 tells us that, number one, the graph below has a correlation coefficient of 1.0, meaning very strong upward trend. That doesn't mean the steepness, it just means that all the data points wind up in close to a straight line. It says, what do you think a correlation coefficient of 1.0 means? Well, I just told you that. So knowing that, what that means, go on to number 2, because it's asking, what do you think a correlation coefficient of -1.0 means, and which one of these is a correlation coefficient of -1.0. And then again, we have the same 6 graphs here. It says match correlation coefficients -0.8, -0.4, 0, +0.4, and +0.8 with the other 5 scatter plots. We picked one in number 2, used the other 5 to match up with these different correlation coefficient values. For parts B through E, I just want you to do 2 things. You don't have to read through all of this. I just want you to look at the graphs. We have one on B, one on C, one on D, and one on E. And for each of those, I want you to estimate the correlation coefficient and explain how you came up with the decimal value that you did. And then write coordinates of 2 outliers from each graph and explain what that means. Okay, what do those outliers mean? So you'll probably want to draw a line of best fit. Decide what your correlation coefficient is based off of that, and then go find a couple of outliers. So do that for B, C, D, and E. Reminder again, our ACEs for 4.3 are 6, 8, 19, and 25. Hope that helps you begin to understand correlation coefficients and outliers. And if you have any questions, I look forward to answering them in class.